Hey there, Prof. Aram here, and in this video I'm going to talk about the rate of return and the number of periods. So we're going to use the same formula that we had for compounding and discounting and rearrange it to find the rate of return and your investment horizon or the number of periods. So let's get to it. In finance, it happens a lot that we want to determine the rate of return on an investment. So you know that you want to invest X amount today and you know that you will receive Y amount in the future. So you want to know what kind of rate of return you're getting in this investment. So let's say your friend tells you that if you give him, or if you lend him $1,000 today, he will return $1,500 in 6 months. So you want to know what kind of rate of return you're getting if you lend your money to your friend. So we call this implied rate of return, a rate of return that is implied by a future value and a present value, two cash flows at two different points in time. So to find that, we are going to go back to our trusted future value formula. And we know that if you want to find the future value, you compound your present value at the rate of interest for t periods. So if you rearrange that, your rate of return would be the ratio of future value over present value raised to the power of 1 over t minus 1. Let's look at an example here. Suppose you're offered an investment in which you put down $2,000 today and you'll receive $5,000 in 10 years. What is the rate of return, or what is the implied rate of return for this investment? So you look at a period of 10 years. So you're investing $2,000 today and you will receive $5,000 in 10 years. You want to know what is your rate of return, what is your R, what is your interest rate. So as the formula showed, your rate would be your future value over present value raised to the power of 1 over 10 minus 1. So let's use the calculator to find the answer. So the thing about this time value of money function is that if you have 3 of the 4 inputs, you can calculate the fourth one. So we have 10 years for our investment horizon. We are investing $2,000 today and we'll receive $5,000 in the future. And then we want to compute the rate. Oops. Did you all get this? Did you all get error 5? So hang in there. Let's do the same thing in the Excel sheet. So we have $2,000 present value, $5,000 future value, and 10 years to maturity. And if we do the same thing here, so here we're solving for a rate. Number of periods is 10. Payment is, we don't have payment right now. Present value is, present value is 2,000 and future value is 5,000. If we do this, you also get an error here. So the error that you get in the calculator or in the Excel sheet is due to this sign convention that we had. Remember, in finance, we have two types of decision, financing or investing decisions. And because of that, for example, financing, you will receive the cash flow today and you have to pay the cash flow in the future. Or for investing, you have to invest today, there's a cash outflow and you will receive the cash flow in the future. You have to follow this sign. One of the two, either present value or future value, should be negative. They should have opposite signs. So let's go back to the calculator. I'm going to change the present value to negative 2,000 and then compute the rate again. Now I get 9.6% for the rate. If you do the same thing in Excel, change this to 2000, now we get the same answer here, 9.6%. Like it's actually, right? 9.6%. So sign convention is extremely important here when you want to calculate the rate of return. So let's do another one. Suppose you have a 1-year-old and you're planning to provide $75,000 in 17 years towards his college education. You currently have $5,000 to invest. So your present value is $5,000 to invest, and you want to have $75,000 in 17 years. You're trying to find an investment that makes this happen. So we want to know what kind of rate of return we need to achieve this financial goal of reaching $75,000. Again, your R is going to be 75 over 5,000 raised to the power of 1 over 17 minus 1. Okay, so let's go to calculator. I'm going to clear this first. And then we have 75,000 for future value, 5,000. Now I remember to put the negative sign here for present value, and then we have 17 years to achieve this goal. What kind of rate of return do we need to get to this point? 17.27%. Let's do the same thing in Excel. We are calculating the rate. Let's just do the drop down menu for this one. So for the interest rate, we need the rate. So for rate, you have the number of periods, which is 17. No payment. Present value is 5,000. And future value is 75,000. Then you get the same rate that we got from the calculator. So you can calculate the implied rate of return easily. The next one is when you want to calculate the number of periods. In other words, you know your rate and you know how much you have to invest and you know how much you want to get at the end of your investment horizon. You want to know how long does it take to achieve this financial goal. To find that, we go back to our future value formula and rearrange it. In this time we solve for T, or the number of periods. So T is the natural log of the ratio of future value over present value divided by the natural log of 1 plus the interest rate. So let's see an example. You want to retire a millionaire and you have $50,000 to start your investment today. Assuming that you can earn a 12% rate of return, how many years does it take for you to retire? How many years later you can retire? So you have 50K to invest now. That's your present value. And your future value is, of course, $1 million because you want to be a millionaire. And you know that there is an investment that provides an interest rate of 12% or a rate of return of 12%. All you need to know is how long does it take for you to achieve this goal. So let's try this. First of all, clear the time value of money function, and then we have $50,000 to invest. Make sure you follow the sign conventions, the negative 50 and then you want to have $1 million in the future, and your rate of return is 12%, so you're computing for N here. So it takes 26.4 years to achieve this goal, to become a millionaire. We can do, again, we can go back to Excel and do this. We find NPER this time. The rate is 12%. Your payment is 0, so I'm going to leave it as that. So present value is 50,000 and future value is going to be $1 million. Guess what? I'm going to get an error now because these two are both positive. So we need a negative sign in front of our present value. That will give us the same rate of return that we had using the calculator. And finally, you can use this rule as an approximation. We call this a 72 rule. So the number of periods it takes for you to double your money, so this is only for doubling the money, is 72 over R. So this is how long will it take. So let's look at an example. How long will it take for you to double $10,000 if you earn 5% annually? All you have to do is just do 72 over 5, which would be 14.4 years. Keep in mind, 72 rule is just an approximation. If you do actually calculate the exact, and it would be 14.2067 years. So pretty close. That's why this is just an approximation, but it usually gives you a good ballpark of how many years or how many periods does it take for you to double your money. I hope you find this video useful, and thanks for watching.